So remember, what is every single x-intercept? Every single one in the universe. X, comma, 0. What is every single y-intercept in the universe? 0, comma, y. This g of x, how do we write it if we're graphing? What is that, the x or the y? That's the y equals 1/2 x minus 2. There's an x, there's an x. Can I change this red x? Am I allowed to change it? No, because I have an x there. There's a y, there's a y. Can I write 0 there? Yes, because this y is 0. So, 0 equals 1/2 x minus 2. Whenever we see one letter, our job is to do what? Isolate it. So I'm going to add 2 to both sides. 2 equals 1/2 x. How do I get rid of this divided by 2? Multiply by 2. What do I do to this side? Multiply by 2. And 4 equals x. What do you see right there? X. What does x equal? So what can I write right there? So one of the points on this graph is 4, 0. Should I put it on the graph yet? Why not? What if the y-intercept was a fraction and I had to change things? So let's change things, or let's check. What letter does that 0 represent? That's an x. What letter is that? X. So if I put 0 there, I'm in business, correct? So y will equal 1/2 times 0 minus 2. Well, doesn't the y just drop out then? So y equals -2. What letter is that? No, what letter is it? Y. What does y equal? So now I can write 0, -2. Now do I have them both? Can I graph it now? I put one dot at 1, 2, 3, 4, 0. I put the other dot at 0, -2. And what should I do with that? Connect it, because it's continuous, right? Now, will that pattern happen forever? Yes. So I went up 2 and over 4, right? So where will the next dot be to the right? Up 2, 1, 2, 3, and over 4. Then where would the next dot to the right be? Same thing, up 2 and over 4. Where will the next dot to the left be? Down 2 and left 4. That was 3, idiot. And where will the next dot to the left from there be? Down 2 and 2, 3, 4. And that makes my forever line. Can everybody deal with intercepts? Now, the concept you learned is that every x-intercept is that and every y-intercept is that, yes? The skill you learned is that whatever is here becomes an x. Whatever is here becomes a y. Is everybody cool? Okay. That's the first thing you have learned. That is graphing by intercept. Now, notice this one has a new title. Slope intercept form. Well, we know what an intercept is, and we also know what a slope is, right? We ski on a slope. A slope's a hill, yeah? We know slope from our last unit, because if I was going very fast on a distance time graph, what would the graph look like? It would be very steep, yes? Because I'm doing a lot of distance in a little bit of time. What if I was going very slowly? It would be very shallow, yes? That's the slope. So we know it as rate of change. We check the dv and we divide it by the iv. That's what we do here. Now, look at this equation right there. what part of that do you already know how to deal with? The x and y, right? Because if I told you that there was a point at 4, 2, where would you put that 4? At the x, right there. Where would you put that 2? At the y, right there. So there's just 2 other letters there that are bothering us, yes? Well, m equals slope. And we know slope is the rate of change. And we know that every rate of change is the dv divided by the iv, right? But not really the dv divided by the iv. It's how much the dv changed divided by how much the iv changed, right? Because that's what we did here. We went up and over. Everybody cool? So really what slope is the change. A triangle is the Greek letter delta. And in science and math, it means a change. So it's the change in the dv divided by the change in the iv. Now, on a graph, is there dv and iv? On all these graphs, have we had dv and iv? Really? We've had y and x, haven't we? Right? So if dv and iv worked last unit, and this unit we're only dealing with numbers, not real life, isn't this also the change in y divided by the change in x? Because we put the dv up and down, we put the iv side to side, right? Everybody cool? Yeah, they're both, the triangle's spelled delta. Right? Okay. If you don't like the word delta, it's also the difference in y over the difference in x. Now, what's the only letter left? B. B, if you look back on the last 2 things we graphed, that's in the B spot, isn't it? Right? B, -2. That's in the B spot, isn't it? 3. What is B? The y-intercept. And that makes sense, doesn't it? Because if x was 0, we'd have the y-intercept, wouldn't we? And 0m would cancel it out, and I'd be left with just b. Everybody understand? B is the y-intercept. That's okay, it'll catch up. Positive b equals a positive y. Negative b equals a negative y-intercept. It'll catch up in a second. Everybody cool? All right, now let's look at our situation here. On the bottom left, I have a line, yes? Right here. Everybody cool? That won't catch up. Is this line right now on a graph? No. Let's put it on a graph. Everybody draw a graph like that, off to the side, so the center is up here. Everybody good? Okay. Does this have an x and a y-intercept? Excellent. There is my y-intercept. There is my x-intercept, correct? If I wanted to check the slope, or the rate of change, I would need to check the y's over the x's, yeah? So here I am. If I go up, what is happening to my y values? Are they getting bigger or smaller? Bigger. So that's a positive change, isn't it? So right here would be positive y. And if I go this way, what is happening to my x's? Are they getting bigger or smaller? Bigger. So that's another positive change, isn't it? So that's a positive change divided by a positive change. If I divide positive by positive, what do I get? What kind of number? A positive number. So this is what we call a positive slope. Now, somebody always says, well, Mr. Myers, what if we go the other way? What if we go the other way? Down is what? A negative change, right? And then left is what? A negative change. What's negative divided by negative? Still positive. Everybody understand? Okay. Well, let's look at this one. Here, up to here. If I go up, what is that? Positive. If I go left, what is that? Negative. So this is a positive divided by a negative, isn't it? So what will this slope be? Negative slope. And obviously, if we reverse it, duh, that is the negative, and that is the positive. Two different signs makes for a negative. Is everybody good? All right, now, these two are the weird ones, aren't they? Right? So, if I go from there to there, what was my change on y? On y. It's positive, isn't it? Divided by, what was my side-to-side change? Nothing. Can I ever divide by 0? No. This is what we call undefined, or an infinite slope, which makes sense, doesn't it? You could ski down this, but do you ski on this? No. You fall. Right? Can't ski on it. Lame. What about this one? Is it the same thing? What's my up and down? 0. What's my side to side? Positive or negative, doesn't matter, right? Can I divide by 0? Can 0 be divided? No, but it's not infinity. What is it? It's not undefined. I have no pizza. Let's cut it in half. How much pizza do I have? 0. This is a 0 slope. This is infinite because you would fall. This is 0 because you wouldn't move at all. Everybody understand? All right. Now, slope, we already know slope by two names, don't we? Slope and rate of change, right? And now we know it by difference in dv over difference in iv, difference in y over difference in x. M, slope has 100 names. How many times have I said the word slope today? A lot. How important do you think slope is? Very important. For the rest of this unit and next unit, slope is the first thing you should find if you can. You will use it all the time. You will also use it all the time in physics and in higher level math if you go on further. Slope is an extremely important measurement. We are only dealing with slopes of straight lines. As you get higher and higher in math, you will deal with slopes of curves. That's calculus. You don't have to worry about it till then. We deal with straight lines. So we know slope as m. We know it as, we've written down a bunch of other things. We're going to write a couple of other ones here. Slope is also the rise over the run. Rise, up and down, just like it means in English. Run, side to side. It is also, if I have one y value and I subtract the other y value, does that give me the difference in y's? Right, but if I write y minus y, what's the answer? 0. So I can't write it like that. We have to recognize that there's two of them. So we write y2 and y1 over, what's this one going to be? x2 and x1. Plus all the other versions of slope. And slope can be, what are the four things slope can be? Positive, negative, undefined or infinite, and 0. Everybody cool? All right, let's put this into practice. Turn the page over. Now remember, y equals mx plus b. What's the m? Slope. What's the b? the y-intercept. Now I'm going to use different colors for all of these. I'm going to do this one in red. Where can I start? Can I start with a slope or can I start with a y-intercept? Which one of them is an actual point on the graph? Y-intercept. So what is the y-intercept for A? Look again. -4. Where is -4 on this grid? 4 down. From 0, right? 1, 2, 3, 4. There is my first point. I need how many points before I can make a line? 2. So I need a second point, don't I? How do I find that second point? Nope. Slope is rise over run, isn't it? So 2 is really what number? How should we properly write 2 if we weren't lazy? 2 over 1. Isn't that a rise over a run? So how do I do a rise of 2? I go up 2. How do I do a run of +1? To the right 1. How long will that pattern continue? Forever. In which direction? Right and left. So if I wanted to go left from here, where would I go? Down 2 and left 1. And now do I have 3 in a row? And I'm guaranteed good, right? Everybody agree? So I can connect the line. Pardon me? Every single number is always over 1. We just don't write it because we're lazy. Okay? Everybody cool? Okay, let's do B. I'm going to do B in blue. Where do we start? On which axis? The y-axis. Why do we start there? Because it's the y-intercept. So there's my starting point. What's my slope? -1. So how do I do -1? Down 1 gets me my negative rise. Then what? To the right 1 to get a positive. And if I wanted to go to the left here, what would I do? Up 1, left 1. Could I go up 7 and left 7? Would that work? Is 7 divided by -7 -1? Could I go up 5,000 and left 5,000? Could I go up a half and left a half? Yes. Everybody understand? And how long will those dots continue? Forever. So can I go ahead and make that line? Sure. I'm going to use my straight line tool. That doesn't work very well sometimes, but I'm going to use it. Your straight line tool. Hear what I did there? Stop it. All right. What's next? C. Where can I start? +5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And what's my slope? Look again. -1 over 3. So how do I get my -1? I go down 1, and then how do I get my +3? I go right 3. 1, 2, 3. What if I wanted to go left? Where would I go? Opposite. So I'd go up 1 and left 1, 2, 3. And how long will that continue? Forever. Could I go up 6 and left 18? Why? Because 6 over 18 is 1/3, right? Could I go up 24 and left 72? Yeah, I could. I'll get it. Go for Myers. Oh, they hung up on me. How rude. Oh, I thought they were going to ask if my refrigerator was running. Then you say, yeah, and then they say, better go catch it. Green line. That was not the straight line. It's supposed to be the straight line tool. It doesn't work very well. I already could have drawn it freehand. There we go. And last one. You guys choose the color. Pink it is. This one's tricky. What's the y-intercept? 0, because there isn't one. There's no number written there. And what's the number we don't write? 0. What's the slope? What kind of 1, Tushar? Positive 1. So could I go up 8 and write 8? Could I go up 4 and write 4? Could I go up 1 and write 1? Yes. I'm going to make it a little bigger. So I'm going to go up 1, 2, 3, 4, 5, and left 1, 2, 3, 4, 5. And then I'm going to use my straight line tool. Oh, almost perfect. You guys can laugh at me all you want, but you try to do it. No. All right. Is everybody good? Now, this stuff is all stuff from the last unit, yeah? F of 2. What color line should I be looking at to do the F of 2? A, the red one, right? Is that an X or a Y value? That's an X value. So I go out to 2. And what is my Y value there? 0. The F of 2 equals 0. Where should I be looking for B? The green line. Is that an X or a Y value? X. So I go out to 1, 2, 3. And I go up to the green line and I find it's right there. What is it? 4. Holy smokes. Is that an X or a Y value? Look again. That's a Y value. What color should I be using for G of X? Blue. So Y equals 4. So I go up to 1, 2, 3, 4. And then I got to go all the way out here to find it. What's my X value? -4. Good job. And where do I go for that color? We know it's the red one. Is that a Y or an X value? That's a Y equals -1. So I go to -1. And then I got to find my X value. What is it? Right there, correct? What would you say that is? 1.5. And that is what it is. Everybody understand? Count up, count over. If it's positive, it's up and... If the slope is positive, you go up and right or down and left. If it's negative, we go up and left or down and right. Excellent. Stop it, you guys. How dare you be that good that quick? All right. Okay, please notice. Page 190 deals with the intercepts. This is your homework from a couple of days ago. Right? That stuff we did the very first day. X, 0, 0, y. The next page is slope-intercept form. This page is y equals mx plus b. Now, hopefully you notice that this is a pretty solid pattern, right? If you do 10 of them and you get them all, are you in good shape? If you do one of them and get it right, that might be good luck. Everybody understand? Do I need to do 100? Maybe not. Okay? That's your job tonight. Page 190 and 191. And I'm giving you lots of time to work on it. Right? Tomorrow, we'll go over your test. And we're actually going to go over this a little bit, like some questions from here, because this is very important to going on. See how there's 5 more lessons in this unit? They're all based on slope. You got to understand slope in all of its forms. Everybody cool? Go.